Dr. G. Poyyamoli. He is adjunct faculty at JSS Academy of Higher Education and Research. So may I request you, sir, to please present on mountain tourism as contributing to climate change. Over to you, sir. Please turn on your mic, cam on, and share your slides. Thank you.
Hi, everybody. Very good morning and good afternoon and good evening to everybody. Can you hear me? Can you hear me?
Yes, loud and clear.
Okay.
Please go ahead.
I'll share my slide. Just a minute. Can you see my slide? Is it visible?
Yes.
Okay, the title of my presentation would be Mountain Tourism as Contributing to Climate Change. At the outset, I wish to thank the Grassroots Institute for inviting me to present this special lecture. This slide gives you the outline of my presentation. The first part will be dealing with the mountain resource characteristics like diversity, marginality, accessibility, fragility, etc., etc. The second part deals with the tourism growth rates in the mountains, an overview of it and the impacts and root causes for GHG emission. Thirdly, we will look into what are the tools available for GHG inventory in mountain tourism. And later on, we'll go into a case study of mountain tourism for climate change. And finally, we'll end up with the sustainable strategies for low carbon mountain ecotourism development. So this slide tells you bird's overview of the mountain areas throughout the world, major mountain areas. As you can see, the mountain areas are spread over all the continents, and they cover about 27% of the Earth's surface, which include more than 475 protected areas in 65 countries. And there are biosphere reserves, there are protected areas, national parks. They attract a large number of tourists which are attracted to nature and culture. We can promote ecotourism or community-based ecotourism, nature-based tourism or wildlife-based tourism. Mountains account for 50% of the world's biodiversity hotspots. We all know that. And most of the beautiful landscapes, scenic beauty, rich habitats, biocultural and heritage diversity, they attract a large number of tourists. And 15 to 20% of the global tourism revenue is derived from the tourism, accounting to $140 billion per year. The Alps alone account for 7 to 10% of the annual global tourism turnover. So from these statistics, you can visualize the importance of the economic importance of tourism, especially the mountain tourism throughout the world. Next slide. Just a minute. Okay. Mountains, if you look at mountains, they actually support 12% of the world's human population, where they live in the mountains. Another 14% live very close to the mountains. And about half are concentrated in the Andes, the Himalayan, Himalaya, Hindu system, and a variety of different African mountains. And you see the International Mountain Day, 11th December 2021, is going to be focused on sustainable tourism theme. So this particular title of my paper, which talks about climate change, is very relevant from this International Mountain Day, December 2021. Next slide. Coming to the Sustainable Development Goals and its linkage to mountain tourism, we must refer to Sustainable Development Goal 13, which talks about reducing climate change. And almost all human activities, they generate greenhouse gases, and tourism is no exception to the rule. So we have to understand what are the linkages of GHG emission from tourism, what are its impacts on the economy and livelihoods and the environment. It's interesting to note that large body of literature exists on the impacts of climate change and mountain tourism, while preciously few studies are available on GHG emissions from mountain tourism landscapes. So this slide gives you a very interesting fact about what are the different types of resources available in mountains, from like natural, cultural resources, event resources, activity resources, and services. If you look at all these things, what are the examples are given here, what are the types are given here, and you see they act as sources and sinks for greenhouse gases. And if you look at various characteristics of mountain resources, diversity, marginality, difficult access, fragility, they have the different attributes and what are the advantages, and all those things are given here. For one of time, I'm not going into it. So if you look at the tourism, we've already discussed about it, how it is important from the economic point of view. One important characteristic feature is that the tourism has a multiplier effect in the ecosystem and the landscape, because there are suppliers, there are consumers, there are local communities. The demand is there for natural resources, not only for the community but also for the tourists. So we have to look at total systems perspective if you really want to know about the implications of tourism on the climate change. And there are various tourism activities on the destination. For example, it can be swimming, safaris, nature walking, visiting cities and national parks, skiing, snowboarding, scootering, bird watching, etc., etc. All these activities require various types of energy resources, where it is fossil fuel or whatever, which actually emit a lot of greenhouse gases. And also the services there, which require, say, for example, waste management and pumping water, etc., etc. They also require a lot of fossil fuel-based resources, which can emit greenhouse gases. So there is a close linkage between tourism and climate change, tourism and biodiversity, tourism and ecosystem services, tourism and livelihoods. They're all interconnected. And climate change is actually affecting all these activities. So sustainability and resilience are very big questions here. So let us move on to the mountain tourism impacts. For want of time, I'm not going to details of impacts because we are focusing only on the GHG emission. Briefly, we can say the environmental impacts are many, talking from the fragmentation of habitat, degradation, deforestation, etc., emission of erosion of biodiversity, monocultures, overexploitation of groundwater, etc. Especially from the point of view of GHG emission, we will talk about the pollution of air pollution, and air pollution actually leads to greenhouse gas emission from various sources, either stationary or moving. It can lead to greenhouse gas emissions. Even waste recycling, waste management, hazardous waste also can lead to greenhouse gases. Actually, there are socio-cultural impacts, there are economic impacts. And then this slide gives you a bird's eye view of the greenhouse gas effect, which is a very simple diagram. The solar radiation, you see the solar radiation actually emits a lot of radiation, and a part of it is reflected back to space, a part is absorbed by the atmosphere, and a part is emitted from the earth, and infrared radiation is escaped through the atmosphere, and finally it is absorbed and re-emitted by the GHG molecule. So there is a greenhouse gas effect here, as a result of which average surface temperature has increased from 1.5 to 2 degrees centigrade by the mid-21st century, if there is not a reduction of greenhouse gas emissions. Global surface temperature was 1.09 degrees C higher between 2011 to 2020 than between 1850 and 1900. And it has triggered a lot of storms, heat waves, forest fires, droughts, glaciers, melting ice, and flash floods, which we are witnessing today. And this is a very interesting slide, which gives you a bird's eye view of the different greenhouse gas compounds. What is the pre-industrial concentration in ppmv and concentration in 2018? What is atmospheric lifetime, etc., etc. So very interestingly, you can find here that it is not just the concentration which is very important, but also the atmospheric lifetime. For example, if you look at the sulfur hexafluoride, which has a very low concentration in atmosphere, but it has a very high atmospheric lifetime. For example, it is 3,200 years. So this is a schematic representation of the fuel and energy consumption in different tourism phases. Imagine that you are departing from your home, and then you are reaching the destination, and there is fuel consumption from at each and every stage, from your home to the airport, and airport to the destination, and then from the destination to various places through cars, trains, buses, etc. And then you see in the destination, fuel consumption is there for heating, local mobility, for sanitation, etc. And then source-wise, sector-wise activities for various greenhouse gas emissions are given here. And then there are various tools available for greenhouse gas emissions. For want of time, I'm not going to the details. Let us move on to the next slide. There are three scopes for GHG carbon emission accounting. Scope 1 is direct GHG emissions from all sources, stationary and mobile. Scope 2 is indirect GHG emissions from purchase of electricity, and 3 is indirect emissions from upstream and downstream activities. This is a very informative slide. It gives you the various modes of transport and comparative emission of GHG emissions. As you can look at it, the bottom is a ferry, the minimum one, maximum is airplane 0.82. Coming to the scope 3 emissions, which is very important at the local level. The inputs for like food and drink, cleaning materials, visitor travel, water supply, power supply, and output and some water discharge and treatment, outsourcing, for example, laundry, accounting. So all these activities, scope 3 emissions are very important at the local level. Coming to the tourism and climate change metrics, various tools are there, various terms are there, which are very important. I'm not going into the details of it, which you can see later on. And what is important is the emission factor, which is given here, the formula, etc., etc. Next slide gives you what is radiative forcing, what is global warming potential, global temperature change potential, carbon dioxide equivalent. Definitions are given here clearly. And then what is the carbon footprint, carbon intensity, representative concentration pathways, RCP 2.6, 4.5, RCP 6, 8.5, and etc., etc. And the global warming potential formula is given here. It is a function of radiative forcing of particular gas over radiative forcing of carbon dioxide over a fixed time scale. And there is a GHG equivalencies calculator, which we can calculate from the sources given here. If you log on to the website, you can calculate the GHG equivalent for various emissions. And for case study, I have chosen the following one, Unger et al. 2016. Title of the paper is Energy Consumption and Greenhouse Gas Emissions Resulting from Tourism Travel in Alpine Setting, Mountain Research and Development Journal. And the web link is given here. And as all of us know, alpine tourism has been repeatedly identified as one of the industries most vulnerable to climate change. And the model of alpine tourism and transportation was developed and applied to the mountain municipality of Alpha of Australia and a role model for sustainable year-round alpine tourism by the authors. The study's objectives are to analyze Alba's energy demand and GHG emission patterns and the potential of renewable energy in the region, and to initiate the development of an optimized and autonomous energy supply system, pursuing the concept of a carbon neutral destination. From a systems analytical perspective, three major sectoral elements can be visualized: skiing and recreation, transport and housing, including accommodation. They have used GIS-based tool for calculating energy consumption and GHG emission for tourist transport to and from a single destination using emissions and demographic data from different sources. This article focuses on transport part of the system, as origin to destination transport accounts for 57 to 86% of the GHG emissions from other mountains. QGIS, an open source GIS, was used to create a density raster map of the geocoded visitor points. Heat maps are based on kernel density estimation. 235 visitor sending hotspots or hubs were defined, generalize, and calculate journey distances. This was exported to PostGR, SQL, and PostGIS spatial database for further calculation. And the map is given here on the right-hand side. The number of geocoded visitors associated with each hub was extrapolated to statistical population using the following equation. And the various parameters are given here. Total amount of person kilometers traveled was calculated based on the distance from the visitor hubs to Alphabet for 4 modes of travel, like private vehicle, bus, train, and airplane. And formula is given here, where PKT overland is the total number of person kilometers travel, visitor hub and RRD hub, all these things are given here. The formula is given here. You can calculate the total number of kilometers traveled, destination returns, or PKT overland and PKT are added to PKT total. Energy consumption for each mode of transport was calculated as direct energy and cumulative energy, includes the energy used during the entire production process. Emissions were calculated as the carbon dioxide equivalent to account for the full GHG potential. Values for energy consumption and GHG emissions of private vehicles were derived from the open source database. For energy emission values for PKT, a load factor of 3% per car or 30 per bus and 131 per airplane were assumed. This slide gives you energy consumption and GHG emissions calculated by PAT total by energy emission factors. And you can see the private vehicles, bus, train, airplane, what is the fuel type and load factor, energy consumption and carbon dioxide emissions for various types of vehicle. Energy consumption and GHG emissions for different modes of tourism transport alphabet are given here. As you can see, the major contribution is from the private vehicle. The concluding remarks are given here. Both direct and indirect energy use and GHG emissions are incorporated as each contributes significantly to the climate impact of travel. So both energy, indirect energy and direct energy have to be used. With some constraints and required adaptations, the model is transferable to other destinations. Also, a detailed, holistic, and in-depth view of the tourism destination energy consumption and GHG emissions patterns on different spatial and temporal scales and for different sectors is essential to communicate the need for transformative change to stakeholders local residents and visitors. The socio-cultural, institutional, and political barriers have to be overcome to adopt a low-carbon tourism pathway characterized by broader values of adaptation, transition, and behavioral change, which is required. And this is a very informative and very interesting slide, which gives you what are the strategies that can be adopted for sustainable low-carbon mountain tourism, ecotourism development, and which actually look into various factors like what kind of adaptation we have to go for in the transportation facilities, like transportation related carbon emissions, how we can reduce that, ecotourism, greening of scenic roads, tourist facilities like the trash charting for, and then low carbon guidance for policy support, tourist compliance, and feedback mechanism, offset to carbon activities like offset to carbon activities carried out in scenic spots, use of environmentally friendly materials. Then participant attitudes can be through, change through behavioral change, low carbon awareness among local residents, etc., etc. Air quality can be, improved by scenic air pollution index calculation. Water environment, we have to look at surface water quality, monitor its sewage discharge compliance, and then we have to go for biological environment, how we can enhance that through vegetation coverage and biological diversity enhancement. And then how to reduce the carbon footprint body. This actually is, I'm not going into detail of it. And this is my last slide. I'll be very happy to answer if there are any questions.
Thank you so much, Professor G. Poyyamoli, for very informative presentation. Mostly we hear about positive contribution of tourism to mountain livelihoods. This presentation enlightened us on some of the negative impacts and how tourism is contributing to climate change in mountain areas. Thank you very much for this